Hello, Karthikeyan. Am I audible?
Yes, madam.
This is your first live session, right? Okay, then I will start the class today. So, hello everyone. Today for mechanics of fiber reinforced polymer composite structure, this is a live interactive session number 3 by me, Ananya Mandal. Today we are going to take some sample problems which are related to assignment number 4 as next week you are supposed to give assignment number 4. So these sample problems will be useful for you to solve these questions. The first question is, in an orthotropic lamina, the strengths are direction dependent and the number of strength parameters required to specify the strengths of
Hello,
hello?
ma'am. We can't see the slide which you are reading. We are seeing only the first slide.
Okay.
Now, now it's visible.
Is it getting visible? Like if I'm
Yes,
changing
yes,
the
yes,
slides?
yes, ma'am.
Yes, madam. Yes, madam.
Okay, okay. Okay. So the first question is, in an orthotropic lamina, the strengths are direction dependent and the number of strength parameters required to specify the strengths of a unidirectional lamina with reference to the material axis. So as you can see, here it is a lamina. In an orthotropic lamina, we have already discussed what is an orthotropic lamina. So in this lamina, there are two axes, 1 and 2. And for a lamina, we assume that in the axis number 3, the thickness is very less. So we don't consider it, we only consider in 1 and 2, two of the axes. It can be in global axis, you can say x and y. Here we have given the number as 1 and 2 as the principal axes. So here, when we have to define the strength, then the what all parameters we need to define for any orthotropic lamina. So first strength is tensile strength. Now tensile strength will be two. If there are two axes, there will be two types of tensile strength. So there will be tensile strength through one direction. It will be this direction and this direction. Then there will be tensile strength in direction number 2. No, sorry, this is compressive strength. The tensile strength will be in this direction and this direction for axis 1, and for axis 2 it will be in this direction and this direction. So now we have two strengths. Then comes compressive strength. For axis 1 there is compressive strength in this direction and this direction, and for axis 2 there will be compressive strength is this and this direction. So then now we have four strength parameters. Now the next one is shear, in plane shear strength. For any plane 1, 2, which is defined by this axis of 1, 2, there will be an in plane shear strength known as tau 1, 2, which will apply like this. It means that this whole plane is moving in this direction. So it will be kind of a deformation will be there in this direction due to due to shear strength. So now we have five parameters, strength parameters, which can define an orthotropic lamina. So answer will be 5 here. So next question is, maximum stress criteria is this in nature, while Sahil failure theory is this. As defined by sir in the class, there are two types of failure theories. as sir defined in class, there are two types of failure theories: non-interactive theories and interactive theories. Non-interactive theories are those in which whenever a stress is given in one direction, there is a maximum available stress that it can withstand in only that direction. For example, you have given a tensile longitudinal stress in one direction. Then there is a ultimate stress that the lamina can withstand in one direction only. Similarly, in the direction 2 or in compressive. So every parameter, every strength parameter has an ultimate value for it. So they are not interacting with the other. For example, any stress in direction 1 will not interact with the stresses that will be also caused in direction 2. And we don't have these theories don't have a particular uh, limits for when, if the stress is in one, and how much stress will affect in direction 2. So that's why they're called non-interactive theories. And there are two non-interactive theories: maximum stress theory and maximum strain theories. Whereas interactive theories are those in which if there is stress in one direction, then even in the direction in two direction, the stress as well as the not only longitudinal, also compressive strength and the shear strength are all interlinked. And for that, there are other failure theories. Those are Sahil, Hoffman, and Saiwu. They have created equations such that it has its own limit, which includes the stresses and this stresses caused in both one and two direction, which can be tensile as well as compressive and also shear. So they're interacting with each other, and with their interaction, we are getting certain zone in which there will be no failure. So that's why they're called interactive theories. So here in the question they asked if maximum stress criteria is, so here you can see it is a non-interactive theory, whereas in nature and Sahil failure theory is an interactive theory. Now there are mostly numericals in this sample problems. The first one is a 60-degree graphite epoxy lamina is subjected to sigma x, sigma y and tau xy is given. And also the ultimate tensile and compressive strength in one direction, two direction, and the ultimate shear strength is given to us. Now we have to use the maximum stress criteria and access the safety of the lamina and decide which of the following is true. Now maximum stress criteria, as sir has taught, is when the value of sigma 1, sigma 2 and tau 1, 2 should lie in the value in this range, where this one is sigma 1 tensile strength, ultimate tensile strength, and minus of the ultimate compression strength in direction 1. Similarly, tau sigma 2 can be defined in the range between the ultimate tensile strength in direction 2 and the minus of the compressive tensile strength. And tau 1 2 as should be less than the ultimate tau 1 2, or if it is negative, as in the lecture it is also defined the significance of sign. So there it should be more than, if it is negative, it should be more than the negative of tau 1 2 ultimate. So now in the question you can see the values are given as tau x, tau y, sigma x, sigma y, and tau xy. So xy are the global axes that are used, like x direction and y direction. But we need the values in principal axes, which are 1 and 2, which is different because this is a 60-degree graphite epoxy lamina where the fibers are aligned in 60 degree. So it will be like this. The fibers will be aligned in 60 degree. In global sense, this is x direction and this will be y direction. So this is what the values are given to us, sigma x and sigma y. But we need it in the principal axis, which will be here, it will be 1 in the direction of which the fibers are aligned, and there will be direction 2 here. Now there is already this matrix, sir has taught before also how we can change the values of global axis to the principal axis by using a stress transformation matrix. So this is the stress transformation matrix where C signifies cos theta. Here theta is given 60 degree and S is sin theta. When you put the values of cos and sin theta here, you will get the values of sigma 1, 2 and gamma 1, 2 as this. This will be the final values. As sigma xy and tau xy is also given, you will get these values. Now you can see sigma 1 is 51.42. It should lie between, it should be less than 1725 megapascal and should be more than minus of 1350 megapascal. So this lies in the range. Next is sigma 2. It should be less than 40 megapascal and should be more than minus 275 megapascal. So this lies in that range. But tau 1 2, it should be less than 95 megapascal, which it is, but it also should be, it should, if it is negative, then I told that it should be more than minus of tau 1 2 ultimate. So minus 95 and here it is minus 124.95, which is less than minus 95. So that's why the answer will be that the lamina is not safe and the mode of failure is shear. As you can see here, you are getting the value which it should not be. The next question is, given the strength parameters for a unidirectional graphite epoxy lamina, this, it is the same values I think. Using maximum stress criteria, the off-axis tensile strength of a 60-degree graphite epoxy lamina is. Now here, off-axis tensile strength means we have to find the maximum tensile strength sigma x that can be applied here before it fails. For that, we considered sigma y as 0 and tau xy 0 and only sigma x as non-zero. Again, we will put these values in the maximum stress criteria and again we will change in here we will try to find the values in principal axis in the form of the global axis. This is the global axis value we need to find in terms of sigma x, which is in global axis. We can again use the stress transformation matrix. So this is how it will look. Sigma 1, sigma 2 and tau 1 2, and this is the stress transformation matrix, and only sigma x is there, other two values are 0. Then tau sigma 1 2 and tau 1 2, we will get these values in terms of s here is sigma x. Now we put these values in this maximum stress criteria in place of sigma 1 2 and tau 1 2. So this is the final range it should be. To find for s, then 0.25 we will send to the both side and divide, and this is the final thing you are getting. So here you can see the lowest value is 53.33. So we will consider this as the value that of the sigma x should be, that is the this is the minimum stress should be in x direction so that there will not be any failure. So why we are taking minimum, we have to take any value which is the lowest, because over that it will break, below that it will be safest. So we take the lowest one because below that it will be safest in every cases, either in any of the directions, in any of the direction the principal axis is 1 or 2. That's why we took the lowest value here, which is 53.33. So next here the same conditions are given using maximum stress criteria, but here the off-axis shear strength we require. So which is the maximum shear strength that can be applied on it before it fails. So here we took sigma x as 0, sigma y as 0, and tau xy as non-zero. Again we put values and through the stress transformation matrix we got the values in terms of tau. And from here we can see this is the uh, in negatives also this is the maximum value that the tau can withstand, whereas in positives this is the lowest value. So we can say that the tau should be either for maximum it could be 190, and for a minimum range it can go to minus 46.189. So these two are the range for tau. Okay, now next question is given the strength parameter for a unidirectional grass epoxy lamina. These are the values of the ultimate strength. Now we have to use the Psi-Hill failure criteria. As already described by sir, the formula for Psi-Hill criteria was big, and after we took cases and uh, we removed the sigma 3 and tau 2 3 and 3 1. This is the final equation we got. So here we are directly using this equation. Again, these are principal axis, and as we know it is 60 degree. That's why from we have to use the stress transformation matrix between the principal matrix as well as the global matrix. Now the question asks to find the off-axis tensile strength. That means we need to find the sigma x considering the other values as 0. So here you can see we took sigma y as 0 and tau xy as 0. Then sigma x. Again we put the value in terms of cos 60 and sin 60, and we found the matrix of sigma 1, sigma 2, tau 1, 2 in terms of the ultimate the tau sigma x you can say as s. Then we put these values of sigma 1, sigma 2 and tau 1, 2 in this final equation, which should be less than 1 to, so that there is no failure. By solving this equation, we can get the value of 6s equal to 6.6442. It is when it is equal to 1. So we need to have a sigma x which should be always less than this, then only there will be no failure. Next question is similar, only here they ask for off-axis shear strength, that is tau xy is non-zero and everything else is 0. Again we put the values in this matrix for tau and keeping other two values as 0, and we get this matrix in form of tau. We put the value in the Psi-Hill failure criteria and equate it to 1. So we will get the value of tau as 53.862. Next question is the longitudinal and transverse coefficients of thermal expansion for a unidirectional glass epoxy lamina are alpha 1 and alpha 2 is given. For a 90-degree glass epoxy lamina, effective coefficients of thermal expansion in the global axis are. This is a simple conversion from again principal axis to global axis, and we know we need to use the stress transformation matrix for that. So this is the for reference, this is the stress transformation matrix that is used. Again for 90-degree we put the values, but here you can see the alpha xy is divided by 2. We have to take care of this, as shear strain is always divided by 2, and here we are at this before the equations we were doing in terms of stress, and here it is strain, and strain is directly the thermal expansions are directly proportional to the strain and delta T. We put the value for 90-degree here, and we will get alpha x, alpha y and alpha xy values. Next, the longitudinal transfer coefficients of thermal expansion, the same, no, the values are different, are given. For a 45-degree carbon epoxy lamina, effective coefficients of thermal expansion in global axis, similar like what we did in the last question. Again, it will be same. We will use the stress transformation matrix. For cos 45-degree and sin 45-degree, we will put value in this matrix, and we can get the alpha x, alpha y and alpha xy values. Any doubts till now? In any question anyone wants to ask?
I mean, question number 5.
Okay.
So either 4 or 5. Now in this one, so we will get a range of stresses, one positive value, one negative value.
Yes.
So we have to, the question is like, what is the maximum the off axis shear strength. So we have to give them the strength. So here out of positive range is 190, negative range is 46.
Yes.
Now the answer should be
Of the values, that what you mean?
yeah, one of the values. So we have to take the modulus, right? Uh, okay, even if it is negative, we have to take concentrate on the magnitude.
Magnitude here it will be 46.189. That's what you have to take.
So that is the strength. Come to previous question.
While we are defining here the ultimate compressive strength, we taking for the range we are taking the negative, but the values are positive only.
Yes, yes.
That's why.
Come to previous question. Yeah, here we got a positive value of tensile strength as 53.33 and negative range is minus 219.
But
Now,
tensile strength we mostly take positive. As sir taught, na,
yeah,
shear can go negative and positive, the sign varies, but tensile
yeah,
strength is always positive. So this will be the answer.
yeah, correct, correct. Now here, if to the negative side, if I get less than 53.33, if I get minus 25 or minus 36, then the strength will be 36, right?
Okay, huh?
Okay, okay,
It will the strength will never be minus. Minus is just showing the direction. It is not the
okay,
value.
okay. So we have to concentrate on magnitude.
Huh.
Okay.
Okay, the last question. Longitudinal transverse coefficients of thermal expansion for unidirectional carbon epoxy lamina are given respectively. And a carbon epoxy lamina have here the E1, E2, G12 and mu12, all these values are given. Heated from 30 degrees Celsius to 80 degrees Celsius, delta T is given. If the lamina is fully restrained, the stresses induced in the material axis are. Now there are a lot of parts in this question that we have to see. First of all, we got the delta T 30 degree to 80 degree, that will be 50 degrees Celsius. If the lamina is fully restrained, that means there will be no strain changes. And the stresses induced in the material, only there will be stresses and there will be no strains in the global axis we consider. Okay, sorry. So here, first we have to find the relation between the strain and uh, okay. So the lamina is fully restrained. That means there will be no strain change with the change in temperature. For that, strain is directly proportional to the to alpha and delta T. Delta T is given to us, and alpha 1 and alpha 2 is given to us. So this is the form. So this is the equation of coefficient of expansion, thermal expansion with respect to strain. Now to find the stresses, we need this equation will be used where Q, the matrix of the Q can be found by the modulus and Poisson ratio at already taught by sir before. This conversion, this is the transpose of the stiffness matrix. Okay, and these values can be found Q11, by this formula, and E1, mu1, 2, mu21, all values are given. So from there you will get the Q matrix, and stress equal to the Q matrix and strain. Strain, you found the values in terms of alpha 1 and alpha 2 as this. When you put the values in this matrix, we will get the final stresses in 1, 2, and uh, sigma. Tau 12 as the final value here. So the main thing is we need for they have asked for us to they have asked the stresses. So stresses are by this equation directly proportional to the Q matrix and the strain. Now strain, it is fully restrained, so we will put the values of the strain in terms of alpha and delta T. As alpha 1 and alpha 2 is given, from this equation alpha 1, alpha 2 and delta T, we can get the matrix of strain in terms of alpha and delta T. We put the value here and we can get the stresses in the principal axes and shear stress also. Okay. These are all the questions that I had today for discussion. Any doubts? Are there any doubts?
No, ma'am.
Have you done the new assignment? Assignment 4. Have you tried the assignment?
Yes, ma'am. Up to maximum stress theory I have done. Hydrothermal I have to just go through that.
There are even many example questions that sir has also taught in the lectures.
Yes, yes.
And these are a little bit easier than that, but those are also good. That was also good. Swapnil, am I audible? Swapnil, Karthikeyan, do you have any
Yes,
doubts?
madam. No, madam.
Have you started assignment 4, doing assignment 4?
No, madam. Hereafter I will start, madam.
And also these sessions are available in YouTube, like this PPT, and also I think it's already shared in that website, problem solving session. So you will
This,
find this PPT there, and also you can get this interaction in YouTube.
yes, madam. Madam, this PPT when will I expect to we get, madam?
By tonight, the drive link is given. So by tonight you will get.
Okay, okay. Thank you.
Do you have any doubts in like previous assignments that anyone wants to discuss? You have submitted the previous assignments, right? Karthikeyan.
Yes, madam. I have one doubt. I will check and ask question, madam.
You can also ask doubts from this session in the like discussion forum in the website. Anything else from what sir taught or anything anyone wants to discuss? Um, Hello, Rahima.
Hello.
Actually, you joined little late. I am done with the presentation of the sample problems for today.
Okay.
It's already shared to you in the website. You got the mail, right? That the live sessions and all. There is a
Yes.
drive where you will get the PPT and the live session is there in YouTube. So you
Oh,
can go
okay.
through it.
Thank you.
Okay.
Thank you.
So today actually we discussed the assignment 4 sample problems. So these problems can be helpful for you to solve assignment 4.
Okay.
And if do you have any other doubts you want to discuss?
No, not anything specifically.
Have you started doing assignment 4?
Yes.
So by tonight, I will upload it in the drive, the PPT. You can go through the PPT. Okay, then if there are no doubts or anything, I don't think anyone else will join, so we'll stop the meeting here. Thank you. Do you have anything to discuss, Kartika?
No, madam. We will discuss next class.
If you have doubts, you can ask those also. On next class, you can ask those doubts. Next class, I will discuss more sample problems on next assignment. Okay.
Okay, madam.
Thank you.
Thank you.